Was it morning or afternoon? Good afternoon, everyone. Thank you very much for inviting us to speak today, and I'm really looking forward to going out and having a look at the site earlier. But like the wonderfully named Storm project, CHERISH also has a hidden meaning to its name. So what I'm going to be talking to you today about is CHERISH, but that's actually climate, heritage and environments of reefs, islands and headlands. There we go. See what I did there? There you go. And another European-funded project between Ireland and Wales. It's a 5-year project of which we're just very rapidly approaching the end of our second year. The project's got 4 partners. I'm an archaeologist and I work for the Royal Commission on the Ancient Historical Monuments of Wales. I've got Sarah, who's going to be talking after me, who's from Aberystwyth University, the Department of Geography and Earth Sciences. And we also have 2 partners in Ireland, the Discovery Programme and the Geological Survey of Ireland. In a nutshell, really, CHERISH is about understanding the past, present and near future impacts of climate change on the cultural heritage of our coastline and maritime archaeology, and it's focused on Wales and Ireland. The aim of the project is to increase capacity and knowledge of climate change for the coastal communities, and the 3 arms of CHERISH, of which I'm going to be looking at the first 2 today and then going to be handing over to Sarah to look at number 3 that you can see on the slide, is quite often we don't even know what we're looking at or looking for, so that we know how to protect or record the archaeology. In West Wales, in remote coastal locations, we don't actually have a really good inventory of the archaeology that we're dealing with, so we're targeting data and knowledge gaps. But also on those sites that we do know more about, we're looking at different methodologies of understanding the sites themselves, both to understand baseline so we can start monitoring the impact of erosion on these sites, basic things like knowing where the cliff edge is now to knowing where the cliff edge is in 20 years' time, so we can actually say for sure how much we're losing. But also we don't want to just lose the archaeology without trying our best to study, excavate and record what's there before it's lost, almost in effect preservation by record at a number of these sites. So why CHERISH? I don't know if most of you are aware that only a couple of weeks ago the Met Office released the UK climate projections for the future, so the UK CP 2018. What are they telling us for the future of climate in the UK? Well, it's pretty much the same story that they told us 10 years ago of what we're going to be expecting. And in a nutshell, really, that's warmer, wetter winters and hotter, drier summers. But the only difference this time is that they're building into the fact that there's going to be more variation in that climate. And one of those variations you can see quite clearly on this first slide, and that's the impact of weather events such as storms that we all see. I live in Aberystwyth, and every single year in Aberystwyth we end up scraping the beach off of the promenade back onto the beach. We see the structural collapses all the way along the coast, new exposures of archaeology. And so the impact on that, on the coast and on the archaeology, is erosion, accretion, increased flooding that we see all the time. This year, for example, well, I don't know if it's the right word to say, it's an amazing year to see what's happening in the climate. We've had the beasts from the east, numerous storms, and we've had the hottest, driest summer, at least since the 70s. And in some ways for archaeology, there's a positive impact of that in terms of, we've heard it mentioned earlier, in terms of the new archaeology and the new discoveries that have been coming out. And within CHERISH, we have an aerial archaeologist who's been flying up and down the coast of Wales, and we've been discovering all new forms of archaeology this summer, from what looks to be a Roman fortlet just there on the Llŷn Peninsula, to new Iron Age enclosures on the coastal plains down in Pembrokeshire. The slight negative impact on that, as we've already spoken about today, is the resulting fires that also came, and amongst all of that smoke there was a Motte and Bailey castle in the middle of Wales. The other impact we've been talking about, more of the slower burn impact, is the sea level rise, which the new projections show that they're going to be probably considerably larger than in previous projections. And around the coast of Wales, we're probably looking somewhere between probably about half a metre or so up to the end of the century. And that's going to have a major impact on coastal habitats and infrastructure, but also on the surge levels later on in terms of increased saltiness, rising sea levels. The erosion is just going to get so much more. And these are just a snapshot around the coast of some of the sites that we're studying in Wales and in Ireland. But our project's not just about the coastal archaeology that we see, it's also about the stuff under the sea as well. So warmer temperatures mean warmer seas, and the impact that that's going to have on marine ecosystems, invasive species, changes in water chemistry, and you think about the maritime heritage in terms of paleo landscapes, shipwrecks, it's going to have a real impact on the archaeology beneath the sea as well. So what are we doing? Well, we're throwing everything that we possibly can in terms of techniques and technologies to record a number of these sites. We've heard about laser scanning today, we've heard about drone survey today, but we're a multidisciplinary team, so we're bringing with it as well the paleoenvironmental work that Sarah and the geographers at Aberystwyth University are undertaking, as well as luminescence dating. We're looking at seabed mapping, we're looking at shipwreck monitoring and dive monitoring, and also more invasive archaeology. You know, what we want to do at the end of the day is also increase our knowledge and understanding of these sites. So sometimes to do that, you're going to need to dig a hole to see if you can get the dating and more understanding about the sites. We've got a number of different areas across Wales and Ireland. I'm going to look more about Wales today, I'm afraid. And I don't know how many of you know Wales very well, but I'm going to look at a number of different case studies of the types of environments and sites that CHERISH has been studying. We're 2 years into our 5-year project, so we're still in the process of gathering lots of data rather than being able to tell you a whole new story about a site, but hopefully you'll see the kind of techniques and information we're doing. And what I'm going to show you is an island landscape, which is Bardsey Island, which is number 4 on the map of Wales, just there. I'm going to look at intertidal zone in Abersoch, which is also in North Wales, in Gwynedd, which is number 5 on the map. And we're going to look at a hill fort site, a coastal hill fort site, which is at the lower edge of number 2 on the map. And then finally, we're going to fling our way across to the remotest part of Ireland at number 5 and look at one of the promontory forts in County Kerry. So, island landscapes, Bardsey Island, wonderful island, one of the largest islands in Wales that has 1 or 2 permanent residents, but it's more of a seasonal holiday home settlement, never a large-scale population. We don't have accurate metric data for some of the islands and coastal zones of Wales. I don't know what it's like here in England, but the Environment Agency with their LiDAR and scanning has flown a lot of the countryside, so you get really, really high, accurate 25-centimetre terrain models of huge parts of the landscapes. In Wales, that kind of stops before the coast edge and never ventures out to some of the islands. So we're starting to deal with not an entirely blank canvas, because we know about the archaeology on some of these islands, but it's really hard to have metrically accurate data for a lot of these islands to understand, firstly, the archaeology that's there, and also how much it's threatened. So what CHERISH has done is commissioned LiDAR surveys of some of these remote island landscapes. This is a 25-centimetre laser scan of the whole of the island, which gives you really accurate mapping and modelling of the landscape and sites, so that actually using other information such as aerial photographs, you can actually start creating your archaeological map of the island, which is what you can see on the second photograph there. Bardsey is a huge landscape that's been settled since the Mesolithic period. It has thousands of lithics that scatter the site. It's very important. It has an Iron Age settlement, but more importantly into the medieval period of the establishment of a religious centre on the island, so it's become a place of pilgrimage in recent times. And then into the post-medieval period, a farming landscape and a settled landscape. So we have a massive landscape here, but obviously not all of that. The landscape is threatened with climate change from the different scenarios, but the most imminent threat to this landscape is on the isthmus, the very narrow bands that you can see there of soft sediment which is being eroded into the sea. So that's the focus now of the CHERISH project. So we've provided an overview, a map of the whole island, and now we're honing in onto areas of more detail of what we're looking at. And in doing that, we're looking at different ways of recording the eroding archaeology there. We're similar approach to here at Mellor, which is going back and repeat monitoring, repeat scanning, repeat taking measurements on cliff edges so that we can monitor the rates of erosion. We're doing that with the GPS system, using drone surveys to produce models, but also actually going and retrieving the archaeology and speaking to the trust and the owners of the island so they can know what they're looking at to retrieve the archaeology as well. What we have coming out of this soft sediment sands of this coastline is cremation burials that we stumbled across this year. We've extracted numbers areas of bone, which is now going off for dating so that we get a dating of these sites. And this isn't going to be here by the time we repeat visit this site next year. You can see just stormophilia, you can see the storm deposits that are there on the site from all of the storms, and you can start plotting the impact of the storms, how fast stones are being flung across the island and the impact that that's having, which is on the bottom right, but also, perhaps evidence of much earlier storm deposits that you can see in surviving sections across the site. So you can start building an understanding of the climate and the impact that the climate has had on that island over the years. And what we're seeing, if it's just a basic map really, looking at the first edition Ordnance Survey map with some of the evidence and data we're seeing now, and you can start seeing that's 8 to 10 metres that's been lost in the space of 100 years at this site already, and we're going to start looking at more accurate detail of that and making sure we're doing all that we can to record the archaeology and recover the archaeology in that narrow band before it's lost. So the dynamic intertidal zone. So we've got a number of sites around the coast of Wales in the intertidal zone. Understandably, these require really, really, really regular monitoring because it's changing all of the time. And in our intertidal zone here, we have a number of shipwrecks, and just hopefully the image on the right there shows you the same shipwreck and the difference and changes that's happening in terms of events and storms, where one day all the sand has been stripped away and revealing the shipwreck and is probably taking away a lot of the archaeology with it. Other times it's being covered over by sands and silts, and then other times it's being stripped away again. So what we're doing is carrying out regular monitoring of these sites, but also akin to what I'm sure Stephanie will be talking about is, luckily for us, as you can see on the image there, we've got a big, caravan park behind us. This is an area where people visit quite often, so it's actually having local people that can start monitoring the sites for us so that they can let us know when anything particularly bad is happening or following storm events, so that we can build up a picture of what's going on at these sites in the tidal zone, in the shift, in the change, in beach profiles. And it's always changing, and we're always discovering more in this intertidal zone. Earlier this year, a huge sway of a peat deposit appeared on the beach here, and this is the first time I think in many, many years that this has been seen, if ever, and we just happened to be very lucky on the day that we were visiting the site. But it also provides us an indication of past environments, past climate, because you get these peat deposits which probably formed around 4,000 or so years ago, which is evidence of a freshwater or brackish environment. These deposits were forming in the bottom of shallow lagoons when the sea was much further out along the coast. And eventually, as sea levels rose and barriers were being breached, the deposits were being covered over. But what you have here is evidence of a prehistoric landscape, in effect. So we recorded animal footprints in the peat deposits, possible trackways, petrified forest remains, but really build up a picture of the environment there at the time, and much later use such as the probably medieval, post-medieval peat cutting, so the peat was being extracted there. And also this year, a particularly low tide, people have walked this beach continuously all the time another shipwreck just pops out of the sand. You know, we just happen to be there and there it is. Nobody's ever seen the shipwreck that popped out of the sand, and we're actually now wondering if this is actually the fossil shipwreck compared to what we always thought of being the fossil, which is the one that everybody knew about. So what we're planning to do in 2020 is, at the minute we're monitoring these sites every couple of months or sort of every 6 months, low tides, post-storm events, changes, but we're going to carry out a much more active monitoring where we're going there at least monthly, if not more so that we can really build up a really clearer picture of the dynamic environment here. Dinas Dintley Hill Fort is the kind of poster child of climate change in Wales and collapsing archaeology. So we're looking at a prehistoric, we think it's a prehistoric hill fort. We haven't excavated it. We have no dating evidence for the site, but by form and type, we think it's pretty sure it's an Iron Age 500 BC type that was settled. Artifactually, we do have some artifacts that become exposed now and then, usually as they're falling out of the cliff face there down onto the beach. And what we seem to get is lots of Roman artifacts. So there's obviously a Roman reuse or reoccupation at the site. The big military base at Carnarvon was just down the road. So there was obviously a lot happening at this point in that Iron Age Romano-British transition. No excavation at the site and no real monitoring to know what's happening to that cliff face, how much is being lost. We don't have really accurate, good baseline data for which to provide a baseline now and then into the future to start monitoring the site. So we've gone out and gathered this baseline data in numbers of ways. Laser scanning is, I think Rob was talking about earlier, which gets us the sort of, millimetre precision accurate data on that cliff face, and following events, just recent wet weather, we've seen more collapse of that cliff face, and it's not so much from coastal erosion, from wave action, it's actually from water runoff on the site that is causing some of the collapse currently. So we can go back out and re-scan certain areas to get that, quantify the amount of information that's gone there. But as I mentioned earlier, it's all well and good creating a baseline, but actually what we want to do is learn about the site before we lose the archaeology. So we're also implementing programs of investigation, a whole new geophysical survey of the site and monument, which brings out a huge number of roundhouses, a bit of contextual understanding in terms of earlier Iron Age field systems surrounding the site, into the later use of post-medieval features. Should also say that in the 20th century, this site formed part of a golf course. So we've got an early 20th century golf course on the site as well. So future excavations will hopefully tell us whether what we're looking at are roundhouses or golf bunkers on some of the site as well. So that will be an interesting fact to figure out. We're also looking at the wider environment, and perhaps Sarah might be talking about this a bit more, but again, we have these peat deposits on the intertidal area there, and that's really helping us get an understanding of the glacial hill and site prior to the establishment of the hill fort, so we can start looking at erosion and maximum extents of the sea level. This is a glacial deposit that's here, and it's just been eroded away, and hence we know where we see the peat, that at that point there's no way the glacial deposit is over the top of that, so we can start working back and look at the regression of the site. And again, just on some basic calculations, we've lost 45 metres of this site, some 45 metres, nearly all of the western rampart in the space of 100 years, and that's only going to get worse. But I'm just going to now very, very briefly, just to show that it's an Irish and Wales project, by nipping across the sea to look at Dunbeg site in Kerry. Unlike a lot of the promontories in Wales, whilst this perhaps has some prehistoric foundations, we're looking more into the early medieval period here in Ireland. And this is a site that really has suffered some pretty catastrophic failures over the time. 2014, in 2014 there was a huge major loss on the site, which has now closed the site so that the public can't even visit the site anymore. And again in 2017, 2014 was to do with coastal erosion, 2017 was to do with inland flooding, so the torrents of water that were coming off the mountainside that just swept through the archaeology there. And so using drain surveys and photogrammetric, we can produce models of the site to look at the archaeology and start then measuring the loss. So, just at this site, we've lost over, 3,000 cubic metres of archaeology on this site in the space of 2 or 3 years. And so it's now a case of actually putting in some measures to actually make sure we're recovering as much of that archaeology and understanding as we can. So hopefully I've not overrun too much. I'm going to pass on to Sarah now to talk about the third element of the project, which is the environments and weather history aspect of the project.
Yeah, thank you again for the invitation to join you here today. Louise has provided a fantastic introduction to the broader aspects of CHERISH and some of the sites that we're working on. I'm going to take you a little bit further back into the past. A lot of what we've talked about this morning is about current management, monitoring, future change. And one of the things that we want to understand as part of CHERISH is what's the longer term context of environmental change at some of the sites that we're working at around the Welsh and Irish coast. So we're trying to understand that longer picture of climate change. And as Rose also mentioned this morning, we talk a lot about climate change, but climate change isn't actually what we experience. What we experience is weather. And this quote from one of my predecessors at Aberystwyth sums it up quite nicely, particularly in terms of weather in Wales. We get quite a lot of weather in Wales, as some of the pictures that yeah, we usually get it first. And hopefully it's kind of calmed down a little bit by the time it gets to you. But this map of the weather systems that impact on the British Isles illustrates quite nicely that we get it from all angles, and whichever one's dominant is kind of influenced by the jet stream, which we've already heard about this morning, and how that's a huge influence on the weather we experience, whether we get very stormy weather, whether we get kind of blocking, stable, cold conditions in the winter. So we're really kind of kind of slaves to the jet stream, really. And Louise has shown you some pictures of the 2013-14 storms, which put Aberystwyth on the climate change map in terms of our experiences of the stormiest winter on record, which attribution studies, where climate modellers look at how climate change is impacting on weather extremes, suggest that this kind of event was 20% more likely because of climate change. So each of these dips in this graph here are individual storm events that came across. They're two meteorological stations, one Stornoway and one Valley on Anglesey. So they're giving us an indication of not just individual extremes. I think it's that repetition, the close spacing of extremes, going from one extreme to the other. That's the challenge that we're facing, not just these individual events, but the cumulative impact. And this season was particularly dramatic. So this is what that couple of week period looked like for the first couple of weeks of February 2014, with low pressure system after low pressure system just barreling its way across the Atlantic and impacting on the UK coast. And these are kind of jet stream driven, but we've also heard about the potential impacts of hurricanes as well as the sea surface temperatures warm. You need a minimum sea surface temperature to get hurricanes. If our mid-Atlantic's warmer, we're going to get more hurricanes drifting farther north than they should. So there's kind of lots of impacts, and for us, we're interested in reconstructing storm activity and trying to understand the nature and timing of storm activity in the past, putting dates on key periods of storm activity. How does the frequency and intensity of storm activity that we see in the past compare with what we have now and what we might get in the future? And how does that interact with sea level change? Because sea level change will potentially increase our risks of storms. So what we're trying to do is link together the environmental history and the archaeology, providing some environmental context to our key sites, but also understanding that longer term storm history. And the way we're doing that is with a range of field sampling, so taking sediment cores from lagoons, peat bogs, which can provide a record of environmental change over thousands of years, sand dunes, which by their very nature are produced by storm activity and coastal processes, exposed sections such as the one here, which is on Bardsey Island, which is buried storm deposit, but also looking at archaeological contexts. We're using a whole range of laboratory techniques to analyse our sediments, biological remains, chemical remains, and chemical processes to try to piece together the environmental history. But of course, we can't do that in isolation. We need to date those deposits as well. So radiocarbon dating is our standard technique, but another technique which is very useful in more sandy deposits is luminescence dating, where we can actually date the luminescence from sand grains, and my colleagues in Aberystwyth are specialists in that. So far we've completed quite a lot of field work around the Welsh coast, and I'm going to focus on that today. Our next target is to go over to Ireland, so we've got quite an intensive programme of field work planned in Ireland this coming year. We've got a range of cores from a number of different sites. I'll just go through some of the kind of coring techniques that we use. Our standard coring technique, which you might be familiar with, is using a Russian corer, which is designed for coring in peat sediments. And there's an example here where we've collected a nice sediment sequence which has got sands and then peats on top of it with so we've got some quite clear changes in stratigraphy which could tell us something about how the environment's changed over time. But we're also working on coastal lagoons, and with lagoons we need rafts. This is a site in Anglesey where we're working. I'll talk a little bit more detail in a second, but we have to build a platform and anchor that, and then use another kind of coring technique called a Livingston corer, which is a piston-operated corer, and we can take metre-length sections. And the good thing about that is it's a closed barrel, so we can use that underwater. And this is Puffy Hump, our CHERISH mascot, who accompanies us on fieldwork and was named by a 4-year-old. She comes out with us whenever she can. So we're sort of using these sort of techniques to get longer sediment cores, and then we have to extrude the cores using a kind of a hand winch to get the sediment out of these metal barrels, and then we take it back to the lab and analyse. And we're also keen to get the very recent past as well, so we make sure that we collect those in clear tubes, so we're absolutely sure that we've got the very surface of the sediment, and we can look at the more the historical record, where we've got an opportunity to link together the sedimentary archive and historical information about storm activity. Sometimes we're working in quite tough environments where hand power alone doesn't get us into the mud that we want. So we have to use a percussion corer, which is essentially a jackhammer with a core barrel on it. And we can use that in much more consolidated environments. And it's also good for going through sand deposits. So we've got a range of techniques that we can apply to our different sites. So these are the sites that we've been working on in Wales so far, all around the Welsh coast, from Stackpole in Pembrokeshire in the south, all the way around Cardigan Bay up to the southwest coast of Anglesey. So focusing on that westward facing, which is the prevailing wind direction of all those storms that come across the North Atlantic. And we've got a range of sites from, say, the archaeological sites, dune sites, and also our coring sites. And I'm just going to give you a few examples now from the northern sites, so on Anglesey, from Llyn Maelog and Llyn Coron. You've already heard about Dinas Dinlley, where we're providing some of the paleo-environmental context of that very important presumed Iron Age settlement there. But first of all, I'm going to talk to you about an archaeological site called Rhyddgaer, which is on the very southwestern tip of Anglesey. It's been excavated by Gwynedd Archaeological Trust, a really rare example of an early medieval farmstead, and one of the finest examples in Wales. They're very rare. And as part of the investigations at that site, there's a whole series of field systems which you can see in the geophysical survey, which is on the left of the screen. The field systems have been excavated as well. And in those, the ridge and furrow field system was preserved underneath a thick deposit of sand. You can see in the left-hand image there, you can see that ridge and furrow structure that's been buried almost as so presumably that happened quite rapidly. But it's quite a thick deposit of sand, and we've got no idea whether that was a very rapid inundation or whether it built up over a period of time. So we're using the luminescence dating through the sequence to try to give us an idea of how long do these deposits take to build up. Just a little bit further north at Llyn Coron, this is a lake that's behind an extensive dune system that extends inland about 2 kilometres at Aberfraw. And that's been worked on previously by colleagues, and the idea there is that there were 2 periods of activity, about 300 years ago and about 600 years ago. But what we don't know is how, whether that dune activity extends further back in time. So by coring the lake, we can potentially get further back in time. And we've been looking at some sediment cores. We've in our sediment cores, the picture at the bottom here, there are 2 clear sand deposits that are interspersed by a period of organic accumulation. So again, we've got 2 distinct units, 2 distinct episodes of increased aeolian activity, increased storminess. And in this picture here, we can see how quickly things can change in the field. We retrieved this core, and there's some woody fragments here that you can see that we've just revealed as we've extruded the core, which were orange. But within a few minutes, they turn black. That process of change can occur very, very quickly. And then just a little bit further north of Llyn Coron, we're also working at Llyn Maelog, which is near Rosnega on Anglesey. And really interesting site here. It's only a couple of kilometres away from Llyn Coron, and we were expecting to find a similar sequence. The idea here would be that any storm activity, you might get wind-blown material, you would get sea spray into the sediments, which we could then help us to reconstruct episodes of storminess. What we've actually got from this lake is a complete post-glacial sequence, which we were very pleased to find. And this is just some examples of some of the basal sediments here. So the very pale grey clay that you see in the bottom image is, we assume, to be the immediate sort of post-glacial. Then we get into more organic accumulation. There's woody fragments here, which we think are Mesolithic environments before sea level rose after the end of the Ice Age. And then we have some grey clay, which was quite interesting. We weren't quite sure what it was, but there was a convenient break in the core, and what we can see in that break, hopefully that you can see it on the end, is the imprint of a shell. So without actually having to do much analysis, we're fairly sure that this is marine, and what we're picking up here is the rise in the maximum extent of sea level during the earlier part of the Holocene. So we've got quite a complex picture of change, of sea level change, sea level rise, sea level fall, and also extreme events just in this relatively short distance. And that's the kind of information that we're working with to try to build up a more detailed picture. So hopefully by what we're doing, we'll get a better understanding of rates of change that can inform the long-term context of the risks that we're facing, develop a chronology of storminess and key episodes of storms, which can provide information on the longer-term dynamics of sites that are priority for key stakeholders. But also I think it helps to demonstrate the coast as an ephemeral landscape. It's one that's constantly changing, and we have to try to live with that change. It's only going to change more in the future, and some of these stories about past change can help us to understand better that we can't stop change, that we have to live with it and adapt to it. And with that in mind, I think it's also worth highlighting, in Wales we have, the Welsh Government has written into law the requirement for all public bodies to consider the well-being of future generations, an act that was that came into being in 2015. So there are 7 well-being goals, and all public bodies have to consider the long-term perspective for communities, for businesses, for the national well-being. So the kind of work that we're doing hopefully can feed into that longer-term, we're using the past, but also looking to longer-term resilience in the future. And I'll finish there. Thank you.
So as an EU-funded project, presumably you've got stakeholders involved in the project. Well, can I just say now, we'd be delighted as Mellor Archaeological Trust to be one of your stakeholders should you feel that's an appropriate thing to do.
One of the next steps might be able to start monitoring more closely a number of the sites that we use as our key baseline study monitoring sites and perhaps looking at the weather stations, and the information from that will actually start building another picture.
Be a really good bit of collaboration,
Yeah,
I think.
absolutely.
Yeah, it'd be fantastic.
I just wondered, is there any other involvement from agencies such as the Environment Agency, you know, with coastal erosion, or people like the National Trust, are they involved as partners? Or
Yes. The National Trust is one of the major landholders of the coastline, certainly in Wales. So Dinas Dynlley is one of their sites, and in fairness, their management policy is accepting the inevitable, which is that's what they're saying about their site, is we can't stop what's happening at Dinas Dynlley, but their strategies is to sort of carry out more research projects, at which we're now fulfilling for them, to understand the site before, and also look at, you know, rerouting. It's also on the National Welsh Coast Path, so they're rerouting the path continuously in line with the erosion that's happening. So whilst they're accepting the inevitable loss, they're still undertaking work to gather as much information as possible in light of that.
How do you actually, because you must have lots of sites to investigate, so how are they chosen?
We selected sites based on status in terms of nationally important sites that were being eroded, on the sort of geology of the area in terms of the different forms of coastline, softer sediment, harder sediment coastline. So those that we know most about, or least most important, but we know little about, so that we can monitor the change. But also those areas where we don't know enough about that area, and that came to a lot of the island landscapes. We don't know enough about the archaeology and the heritage on the remote islands of Wales. So that was the other criteria. It's as well as well-known sites, is about those areas that we don't know enough of. And I think the paleo-environmental sites were selected on probably similar or slightly different criteria.
Yeah, I think from the paleo-environmental perspective, where the archaeology sites are priority, we're trying to get the closest sites that we can to inform on the environmental context. But some of our site selection is driven by what are the best sites to record a regional signal of storm activity. So there's a combination of, you know, we're not always able to get adjacent to the priority archaeological sites, but we're looking at a more regional picture anyway. So it's a combination of both.
It's not really a question. I just want to say to you how much I enjoy reading the information you produce on social media.
That's really helpful feedback, because we've been trying quite a lot to get the word out about the project, and glad that you know, people like yourselves are interested in engaging with it.
Should mention that if you haven't seen, we've brought along copies of our latest newsletter, which are on the table underneath your exhibition. And like all EU-funded projects, there's a freebies in terms of postcards and things to take away. But we're trying to produce a regular newsletter every 6 months that's available electronically as well as printed. And then hopefully at the back of that newsletter you'll see our social media contacts and website information there, and our contact details as well. So, thank you.
The focus seems to be on erosion of the coastline. But I just remember at Harlech Castle that the castle was always on the coast originally, and the land has, the sea's receded in that place. So does this vary around the coast? And the second question is that when you were talking about the shipwrecks, you talked about almost like an ordinary shipwreck and a fossilised shipwreck. And is there a difference between those, and is that difference significant?
Yeah. So I'll take the first question, then Louise will take the second one. So yeah, you're right. I mean, Harlech is a famous example where, you know, one of the sort of gateways into it was assumed to be at sea level during the 14th century, and so I think that's a useful reminder that sea level has changed, and that we often think about erosion and loss, but actually when that sediment's moved, it goes somewhere else. And also, if you think about Dinas Dynlley, when there's a fall of sediment, or you know, that for a time will protect the base of the cliff until that's washed away, and then you get more active erosion. So it's not all loss. So you're absolutely right. It's important to consider that we're looking at change and a dynamic environment, and some things are negative, and quite a lot can be, but there's also some wins as well. Yeah.
In terms of the intertidal zone, so we've got different shipwrecks we're looking at. So there's some on the intertidal zone, which I showed in the slide, where we're looking at the changes. And that wreck was probably a 19th century slate schooner that served the slate industry as well. But the impact of climate change and storminess and what's happening there is slightly different to some of the other shipwrecks, and I didn't really show you any slides about that, and that's being led more by our Irish colleagues who are the maritime archaeological element. So that's actually looking at the shipwrecks on the seabed and the impacts of whether they're timber or iron, you know, the different changes that makes to the changing chemistry of sea levels in terms of invasive species. It could be a worm which seems to be making its way further north due to the warming of seawaters, which is boring its way through these wooden shipwrecks, to the different kinds of formations that sit onto the metallic wrecks and that kind of thing, but also looking at how shipwrecks impact the sea floor in terms of currents and storms and the impact. So that's what the maritime element will be bringing to the shipwrecks under the sea, if that was vaguely more or less what your question was about.